Okay, so welcome all. So today we are this is the continuation of the part 1. Okay, so let's see, there is a numerical. So what is it telling? Determine the ultimate moment of resistance. So it is telling to find out MOR, moment of resistance of a rectangular beam of width 350 with 550 effective depth. So small d is already given 550 as it is written effective depth, so it is the small d already given. Okay, so here the b is equal to 350 mm. Okay, and fck is 30, fy is equal to 250, and 4 number of bar of 25 dia. So let's see how we will calculate it. So it is telling to calculate MOR, moment of resistance. So you know that moment of resistance can be calculated by two way, that is from the compression side and another is the tension side. So we have seen that if uh, we will first take out the value of XU and XU limiting, and we will see if it is under reinforced or over reinforced. If it is under reinforced, we will take out the moment of resistance from the tension side, and if it is over reinforced, we will take out the moment of resistance from the compression side. Okay, so let's find out. So we will find out XU limiting. So XU limiting is equal to K into D. Okay, so what is the value of Fy is 250. Okay, so for 250 the K is 0.53 into D. Okay, so the D is 550, so the value comes to 291.5 mm. Okay, so we will now find out the XU value. Okay, XU is equal to 0.87 Fy AST divided by 0.36 FCKB. Okay, so we will put the values here. 0.87 into Fy is 250 into AST, we will take it out. You see here it is told that 4 bar of 25 mm dia, so we will take out the AST is equal to 4 into pi by 4 d square. Okay, so 25 square, it comes out to be 1963.5 mm square. So the area of steel comes out to be this. So we will put it here. Okay, 1963.5 divided by 0.36 FCK. FCK is, you see, FCK is 30 into B. B is given as 350. Okay, so 350. So this value comes to 112.36 mm. Okay, so we can conclude that, so this is the value of XU limiting and this is the value of XU. Okay, so we can conclude that XU limiting is greater than XU, so it is a under reinforced section. Okay, so what we can conclude again, so the moment of resistance will be calculated from the tension side. Okay, So the moment of resistance from tension side, the formula is, moment of resistance formula is force into lever arm. Okay. So the force, what is the force? The force is 0.87 FYAST into D minus 0.42 XU. Okay. So this is the value. This is the value of force. Okay. And this is the value of lever arm. So we will put the value. So 0.87 Fy is 250 into AST is 1963.5 into D 550 minus 0.42, and XU, we will take this XU, as we know that if the XU is XU limiting is greater than XU, so we take the value of XU into our consideration. Okay. So is equal to 112.36. Okay. So the moment of resistance from the tension side will be 214.92 kilonewton. So one thing you will see, you will calculate this value. Okay. And you have to divide it by 10 to the power 6, because this value will come out to be Newton per mm square. Okay. So we have to convert it to kilo Newton meter. So for kilo, so for this kilo we will multiply 10 to the power 3, and for this Newton, for this mm to meter, sorry, it sorry, it will not, it will come out in, it will come, this value will come out in Newton per meter, sorry, Newton per millimeter. Okay. So we have to convert it to kilonewton meter. So for this kilo, we 10 to the power 3, and for this mm to meter 10 to the power 3. Okay. So 10 to the power 6. So the value we will get from here, we have to divide it by 10 to the power 6, and we will get this answer. Okay. Okay. So the numerical is done. So we will see the next numerical. Okay. So some part has been got cut, I am telling that. Okay. Determine the lever arm and the moment of resistance of the beam section as shown. So it is the diagram given. Okay. So resistance of beam section as given. Use M20 and Fe 250 steel. Okay. So you can see here the B is given as 275, and the capital D is given as 425, and the D naught is given as 35. Okay. So we will first calculate the small d. So the small d will be 390. How it is coming? It is coming from 425 minus 35. Okay. It comes to 390. So this is the effective depth. Okay. So see, we have to calculate the lever arm and the moment. So we have to calculate the MOR. Okay. So we know that for that we have to calculate XU and XU limiting. And for lever arm formula is D minus 0.42 XU. So we have the value of D. We have to just find out the XU for lever arm. Okay. So we will do it one by one. So let's start. So here we will start. Okay. So first we will find out XU limiting is equal to K into D. So see, it is set as Fe250. So the value of K is 0.53 into D, we have calculated as 390. So the value of XU limiting comes to 207.5. 09 207.09 mm. Okay, so now we will calculate the value of XU. Okay, so 0.87 FYAST divided by 0.36 FCKB. So we have to calculate the AST. AST is equal to, see here it is written 4 bar of 16. So 4 into pi by 4 into 16 square. Okay, so the AST comes to 0804.25 mm square. Okay, so we will put the values here in XU. 0.87 FY is 250, AST is 804.25, and 0.36 FCK is M20. So FCK is 20 into B is given as 275. Okay, 275. So the XU comes to 87.86 mm. Okay, so now we can say that XU limiting is greater than XU. So we will use the value of XU only in our calculation, and it is under reinforced. So we will find out the moment of resistance from the tension side. Okay, then let's start. So now we will find out the lever arm. Lever arm is very easy. D minus 0.42 XU. So here what we will do, C is equal to D. The D is 390. Okay, the D is 390 minus 0.42. XU comes to 87 point, this value 87.86 is equal to, it comes to 353.45 mm. Okay, so this is the lever arm. Now what it is telling, see, we have to also calculate the moment of resistance. Okay, so the moment of resistance we are finding out from the tension zone is equal to 0.7 FY AST D minus 0.42 XU. So this value is already calculated, the lever arm, this part. Okay, so this is 353.45, and this we have to calculate. Fy is 250 and AST comes to 804.25. Okay, so we will calculate it. So it is coming 353.45 into 804.25 into 250 into 0.87, okay, divided by 10 to the power 6. Okay, so it is coming as 61.827. okay, so the value of MOR T is coming as 61.827, so kilonewton meter. Okay, so we can write it as 61.3 kilonewton meter. So this is the answer. This is one answer and this is one answer. Okay, so we have find it out. Now see, now there is another numerical, so we will do it also. Calculate the MR, moment of resistance, of a rectangular beam of size 400 into 650. Okay, with number A 3 of 16 dia, number B is 6 of 25 dia, and 8 of 25 mm dia. Calculate the area of steel required for limiting section also. Use M20 415 and assume cover as this. Okay, so I will do one only. You can do the others of your own, as because everything is same. Okay, so we'll start. So we are calculating the number A. You do number B and number C will be the ditto same. Okay, so we are starting. So we have to calculate the moment of resistance. So we know that for that we have to calculate XU limiting, AST, and this only. Okay, so we will get. So let's start. So first we will find out XU limiting. XU limiting is equal to K into D. Okay, so the K value is, we have to Fe 415. Okay, so for 415 the value is 0.48 into D. See, so it is 650 and the cover is of 50, so small d is 600. Okay, so we'll put it here 600. So XU limiting comes to 288. Okay, 288 mm XU limiting. Okay, so now we will find out the AST value. AST is equal to, see what it has told, 3 of 16. Okay, so 3 into pi by 4 into 16 square, so it's coming as 603.2 mm square. Okay, so this is the area of steel. Now what we will calculate? Now we will calculate our XU. XU is equal to 0.87 FYAST divided by 0.36 FCKB. So what it is coming? Let's check. 0.87 into Fy is 415. F1 is 415. So 415 into 603.2, okay, divided by 0.36. FCK is, see here, M20, so it's 20 into B is 400. Okay, so B is 400. So we are getting the value of XU as 50 point, wait, so we have to calculate it. I have not calculated. 0.87 into 415 into 603.2 bracket divided by 0.36 into 20 into 400. Okay, So the value comes to 75.62 75.62 mm. So we can conclude this is the XU limiting, this is XU. So XU limiting is greater than XU. So we will use the value of XU only, and under reinforced. So we will calculate the moment of resistance from the tension side. Okay. So let's check. Yeah. So moment of resistance from the tension side is as 0.87 Fy AST into D minus 0.42 XU. Okay. So here it comes to 0.87 into 415 is Fy into AST is 603.2 and D minus 0.42 into XU is 75.62. Okay, so it will come out to sorry D and D I am writing it here as 600. Okay, so D you will replace it as 600. Okay, so we will calculate it. 600 minus bracket 0.42 into 75.62, okay, into 603.2 into 415 into 0.87 divided by 10 to the power 6. It's coming to 123.75. 123.75 kilonewton meter. Okay, so this is the moment of resistance. Okay, so this is one answer. Okay, so you will do the next part on your own. See, we have to calculate this part. Okay, calculate the area of steel required for limiting section. So for limiting section, what we know. See, we will just go to the top. Okay, so we have to find out mu limiting. Okay, we have to find out mainly the area of steel. We have to find out. We will use this formula: mu limiting divided by 0.87 Fy D minus 0.42 XU. And for this we need the mu limiting. So mu limiting we will get it from here. Mu limiting is equal to Q BD square, and Q we will find out from here. Okay, Q is equal to 0.138 FCK. So we will do it. Yeah, let's do. We will find out mu limiting is equal to Q BD square. Okay, so Q is 0.138 FCK. So this value is for Fe 415 into B is 400. B is 400 and D is 600. Okay, 600 square. So FCK is M20. So if replace FCK. Wait, one thing. Okay, we have to increase it. Just wait. Yeah. Okay, so replace the FCK value by 20. Okay, so let's check what's the value is coming. 600 into 600 into 400 into 20 into 0.138 divided by 10 to the power 6. So it's coming to 397.44. Okay, so it's coming as 397.4 kilonewton meter. Okay, so now we will find out the AST limiting, AST for mu limiting. Okay, so the formula is mu limiting divided by 0.87 fy d minus 0.42 xu, that is xu limiting. Okay, so here we will use the value of xu limiting. Okay, so the xu limiting is 288. Okay, 288 is equal to 397.4 divided by 0.87 fy. Fy is 415. Okay, d is 600 minus 0.42 xu is 288. Okay, 288. So the value comes to 600 minus 0.42 into 288. Okay, so it's coming as 497. Okay, 479. So this is coming as 479. Okay, so now we can do 397.4 divided by 0.87 into 415 into 49. Okay, wait one thing. Sorry, we have done a little mistake. At is because this is in kilonewton meter. We have to convert it to Newton per mm. Okay, so what we will do, we will just multiply it with 10 to the power 6, as because values these values are in mm. Okay, so to bring it in the same value, so what we'll do now, 397.4 into 10 to the power 18, 0.87 into 415 into 479. Okay, so we are getting it as 2297.87 mm square. So this is the AST. Okay, so we are winding up the lecture here. So we will do some numericals of double. Next we will do numericals on doubly reinforced beam. Okay, thank you.